Hello. This little bit is about an example of homomorphisms of algebras, namely algebra homomorphisms. From a specific algebra of polynomials with coefficients in the basic field. So let's fix this basic field of coefficients. And let's look at a particular example of algebra, which is the algebra of polynomials in the variable t with coefficients. In F. And let's choose an arbitrary algebra of F. Or F algebra, let's call it A. So the story will be the story of homomorphisms between two algebras, the algebra of polynomials and the algebra A. And we will restrict ourselves to Unital. Homomorphisms of algebras of F. So the story will be a complete description of such. Let's just analyze the situation. Let's see what the homomorphism should obey. Let's take an arbitrary input for such a homomorphism, an arbitrary polynomial. As a polynomial, it is a combination of powers of our variable and some coefficients. And now let's fix the degree to be t, or just t. Yeah. And then start computing what the value should be. Well, first of all, any polynomial is a sum of terms of monomials, so just writing first the input and using the additivity property of phi. Phi is a homomorphism of algebras, and in particular it is transforming sums into sums. We can now take this compact summation symbol out of our homomorphism and see the sum of the values of this homomorphism on monomials. So this is additivity of phi we used here. Any monomial is a product of a power of t and a scalar. So being an F algebra homomorphism allows us to take these scalars out of phi, and we will now have a linear combination with coefficients in our basic field F of the values of phi on the powers of t. So that step was using the algebra, F algebra property of phi. And at this step we are looking at the values of phi on the powers, and we can use multiplicativity of phi, and using it we can write the values as the value on t to the power I, starting from the 0 power to the whatever is the highest power in our polynomial. So one point here, assuming that our homomorphism is unital for a reason, because here we are using also, on top of multiplicativity, we are using this unitality condition, which really says that the value on 1 is 1. So the 0th power, really the first power we're supposed to analyze, the 0th power is said to be 1, and now we're saying that this is also 1 after applying phi. So that is unitality. That is not just multiplicativity we're using here, but the unitality of phi as well. So all in all, doing this computation, we end up with the answer that the value on an arbitrary polynomial is completely determined by the value on t. Well, the value on t is an element of A. So just knowing these elements, we know the whole homomorphism, should know the whole homomorphism. Well, let's now call it A, little a. The story can be reversed. Starting with any A, we can construct a homomorphism which will take on the polynomial t, on the monomial t, which will take this prescribed value A. And then just rewriting this as a definition of the homomorphism, we will have the following compact answer. F, the polynomial f evaluated on A. Well, we have to really agree what it means. Here is meaning. You could think of a polynomial as an instruction, as a recipe of computing something in any algebra. Because after all, what is a polynomial? It's an instruction of take sums, take a sum of products of scalars and powers of an element. All these instructions can be performed in an arbitrary F algebra. So that's what this evaluation is. So this is the evaluation homomorphism on little a. And scientifically speaking, we have the following identification of two sets. The first set is a set of homomorphisms between F algebras, starting at the algebra of polynomials and ending in an arbitrary F algebra A. And this set is identified by our computation with the set A. Any element gives us a homomorphism of evaluating on this element, and vice versa, any homomorphism gives us an element which we can compute by evaluating our homomorphism on T. And these maps are mutually inverse, so we have this isomorphism. So in the adult language, the algebra of polynomials is the free algebra on one generator. That's it for now. Goodbye.